Hi children, previous class I explained about concept 1 and worksheet 1. Okay, so did you complete that worksheets? If you not complete, once again just you prepare, okay, and do the worksheet. So today I am going to explain about concept 2, that is non-metals. Okay, let's discuss about non-metals and the physical properties, that means general properties. Okay, here non-metals. See, what are the non-metals? Non-metals, here total 22 non-metals are there. Out of 22 non-metals, 11 are gaseous elements, those are non-metals, and one is liquid non-metal or solids, those are non-metals only. Okay, so total 22 elements, 11 are gaseous elements, and next 10 are solids, one is liquid non-metal, that is bromine. So let us discuss about what are those 11 gaseous elements. See here, non-metals, 11 non-metals, those are gases, 11 gases. Next one is liquid and 10 are solids. So total 22 non-metals. What are those? 11 are gases, 1 is liquid, 10 are solids. Now, what are those elements? So, what are those non-metals? Those are non-metal elements. So, first one is gaseous elements. So, you know, hydrogen, next fluorine, next chlorine, next oxygen, nitrogen. Noble gases, helium, neon, argon, krypton, xenon, radon. 11 gaseous non-metal elements: hydrogen, fluorine, chlorine, oxygen, nitrogen, helium, neon, argon, krypton, xenon, radon. These are the 11 gaseous elements. And one is liquid metal, that is bromine. This is bromine. It is reddish brown color liquid gas, that is non-metal. Next one is 10 are solids. You know, that is carbon. Those are, first one is carbon, sulfur, phosphorus, iodine, selenium. These are the 5 non-metals. And metalloids also there: boron, silicon, germanium, arsenic, stibbium, tellurium. These are the 10 non-metals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So one is no need here. This is, so these are the non-metals. So what are those non-metals? Once again, total 22 non-metals are there. 22 non-metals. 11 are gases elements, and 1 is liquid, 10 are solids. These are the non-metals. So if we know the non-metals, so then we'll go to the, so what is the definition of a non-metal? The tendency of an element to gain their electrons. Suppose if I take one element, it gains one electron. If it gains 1 electron, it will get 1 negative charge. If it gains 2 electrons, it will get 2 negatives. If it gains 3 electrons, it will get 3 negatives. So these non-metals will form electronegative. That means anions. Okay. So these are the non-metals, and definition also completed. Then let us see the examples. Let us see the examples for I will take the fluorine and oxygen, nitrogen. These three examples I will take, and I will explain about the non-metals, if they gain the electrons or if they lose their electrons. So non-metals always gain their electrons. Metals will lose their electrons. Metals, if they lose their electrons, will get positive charge. Non-metals, if they gain their electrons, will get negative charge. Metals will form cations, non-metal will form anions. So this is about non-metals. Let us see the examples. Non-metals. Fluorine, I am taking fluorine. Fluorine, first example, fluorine is a non-metal. It gains 1 electron. It gets negative. This is electronegative, nothing but anion. This is mono electronegative element. Next one is second one, chlorine. Chlorine gains 1 electron. This is also Cl minus, anions. This is fluorine is fluoride anion. Cl minus is chloride anion. Here F is the fluorine atom. If it gains 1 electron, it will form fluoride anion. Chlorine is atom. If it gains 1 electron, it will form chloride anion, Cl minus. Next, third example, oxygen. Oxygen gains 2 electrons to form O2 minus. Because to get the stability, to get the inert gas configuration, oxygen takes 2 electrons and forms O2 minus. This is oxide anion, oxide anion. So to get the stability, in the same way fluorine also, to get the stability, to get the neon configuration, fluorine forms F minus. In order to form the Cl minus, Cl gains 1 electron, Cl minus, that is argon inert gas configuration. Here oxygen takes 2 electrons, O2 minus, that is neon electronic configuration. Next, let's go to the fourth example. Nitrogen, atomic number is 7 actually. It takes 3 electrons. 7 plus 3, 10. So it will get N3 minus. N3 minus. This is nitride. This is nitride anion. Nitride anion. This is oxide anion. Oxide anion. This is chloride anion. This is fluoride anion. Okay. So this is about the non-metals. The tendency of non-metal gains their electrons to form their ions, that is anions. Let's go to the physical properties of non-metals. Physical properties of non-metals. So I explained about how many non-metals, how many solids, how many liquids, how many gaseous elements. Next, definition of non-metal I explained. Next, 3 or 4 examples of non-metals I explained. Now going to explain general physical properties of non-metals. So I will continue with the second page. So this is already I explained about this: fluorine, oxygen, nitrogen. Fluorine forms fluoride, oxygen forms oxide, nitrogen forms nitride. This is only that is I explained before. Okay na? Next non-metals are electronegative elements. That is also completed. Next let's discuss about the carbon atomic number 6. See, carbon atomic number 6. Atomic number 6. You have to know about the shell method electronic configuration. Shell method electronic configuration. Here first shell, K shell, we have to fill 2 electrons always, maximum 2 electrons we have to fill. Second shell, according to the atomic number here 6, so that's why two comma 6. So in outermost shell 4 electrons are present. Ikkada 4 electrons are present. Atomic number 6, electronic configuration 2 4, outermost shell 4 electrons are present. 4 electrons are present. So in order to find out the valency of carbon, you should write this is the valency of non-metals. Valency of non-metal. Which is the valency of non-metal? Here carbon is the valency of non-metal. Here in order to find out the valency of non-metal, 8 minus outermost electrons. These are the outermost electrons. So 4. Then you will get the valency of non-metal, that is carbon. Carbon is the non-metal here. So 8 minus 4. So 4. The valency of carbon is 4. Second one, see here, carbon atomic number 6. Next, nitrogen atomic number 7. Nitrogen atomic number 7. So here 2 comma 5. The number of valence electrons 5. Valence electrons means outermost electrons. Carbon valence electrons 4. Because atomic number 6, electronic configuration here EC, electronic configuration 2 comma 4. Outermost electrons, these are the outermost electrons. Outermost electrons means valence shell electrons outside. Here valency of non-metal is 8 minus 4. So total 4. The valency of carbon is 4. Valency electrons 4. In order to find out the valency, 8 minus 4, that is outermost electrons. So valency of non-metal carbon is 8 is equal to 8 minus 4. Valency of nitrogen 7, that is equal to 2 comma 5. So valence electrons, that means outermost electrons, here 5. So in order to find out the valency of nitrogen 8 minus 5. So here valency is 3. Valence electrons 5. Valency is 3. Here also carbon valence electrons 4. Valency also 4. Next, carbon over nitrogen over oxygen. Atomic number 8. Here this is the example number 2. This is example number 1. Okay. Next, oxygen 8, 2 comma 6. Valence electrons, that means outermost electrons 6. Next, in order to find out the valency of oxygen, that is equal to 8 minus 6. The valency is 2. Valency of oxygen is 2. Valency of oxygen is 2. Here carbon valence electrons 4, valency 4. Nitrogen valence electrons 5, valency is 3. Oxygen valence electrons 6 and valency is 2. So these are the examples of non-metals. In order to find out the valence electrons and valency, we have to know about atomic number, electronic configuration, then we can find out the valence electrons, then we can find out the valency. ఓకే, అండర్స్టాండింగ్ అర్థమవుతుంది కదా. ఏంటంటే ఇక్కడ ఏం చేశారంటే కార్బన్ అటామిక్ నెంబర్ రాయాలి, దాని యొక్క షెల్ మెథడ్ ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ తెలియాలి, దాంట్లో ఉన్నటువంటి అవుటర్ మోస్ట్ ఎలక్ట్రాన్స్ ఎన్నో తెలియాలి. అవుటర్ మోస్ట్ ఎలక్ట్రాన్స్ ఎన్నో తెలియాలంటే ఫస్ట్ షెల్లో 2 ఎలక్ట్రాన్స్ తీసుకోవాలి. ఎప్పుడు కూడా 2 ఎలక్ట్రాన్స్ ఉంటుంది, ఎందుకంటే ఒక ఫార్ములా ఉంది, ఆ ఫార్ములాని బట్టి చెప్పాలి అది. తర్వాత వ్యాలెన్స్ ఎలక్ట్రాన్స్, వ్యాలెన్సీ 4, ద సేమ్ అటామిక్ నెంబర్ రాయాలి. ఫస్ట్ షెల్లో కంపల్సరీగా 2 ఎలక్ట్రాన్స్ ఉండాలి. తర్వాత రిమైనింగ్ ఎలక్ట్రాన్స్ ఎన్నో చూసుకోవాలి, ఇక్కడ అటామిక్ నెంబర్ని బట్టి చెప్పాలి. ఇక్కడ 2 కదా, 7 అటామిక్ నెంబర్, 2 అయిపోయినాయి, ఇంకెన్ని ఉండాలి 5 అట్లా. సో మిగతాది కూడా అంతే. సో అటామిక్ నెంబర్ తెలియాలి, ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ తెలియాలి, ఫస్ట్ షెల్లో ఎన్ని ఎలక్ట్రాన్స్ 2 ఎలక్ట్రాన్స్ ఫిల్ చేయాలి, సెకండ్ షెల్లో రిమైనింగ్ ఎలక్ట్రాన్స్ ఫిల్ చేయాలి, అప్పుడు అవుటర్ మోస్ట్ ఎలక్ట్రాన్స్ అంటే వ్యాలెన్స్ ఎలక్ట్రాన్స్ ఎన్నో తెలుస్తాయి. సరేనా, రైట్, దీస్ ఆర్ ద ఎగ్జాంపుల్స్. సో నెక్స్ట్ నియాన్, నియాన్ అటామిక్ నెంబర్ 10. సో వ్యాలెన్స్ ఎలక్ట్రాన్స్ ఎన్ని వస్తాయి ఇప్పుడు, నియాన్ అటామిక్ నెంబర్ 10 అంటే ఫస్ట్ షెల్లో ఎప్పుడు కూడా 2, సెకండ్ షెల్లో 8, మ్యాక్సిమం నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇన్ సెకండ్ షెల్ ఎన్ని ఉంటాయి 8. సో వ్యాలెన్స్ ఎలక్ట్రాన్స్ ఎన్ని ఇప్పుడు 2. దిస్ ఈజ్ అబౌట్ ది నాన్ మెటల్స్. హైడ్రోజన్ కంటైన్స్ 1 electron, helium contains 2 electrons. Hydrogen atomic number 1, electronic configuration 1. So first shell contains only 1 electron. So hydrogen atomic number 1. So electronic configuration K shell 1. Okay. Next helium atomic number 2, K shell 2 electrons. So this is only the outermost electrons 1. This is only the outermost electrons 2. So these are, see here what is given, hydrogen, helium have 1 and 2 electrons. Hydrogen has 1 electron in the valence shell or outermost shell. Helium has 2 electrons in the valence shell, that is outermost shell. Next, let's discuss about the physical properties of non-metals. So you know very well about physical properties. If they don't exhibit, those elements are called as non-metals. What they don't exhibit? Because they won't have hard nature, they don't exhibit lustrous nature, they don't exhibit sonorous nature, malleability, ductility, and good conductors of heat and electricity. If they don't exhibit all these elements physical properties, those elements are called as non-metals. What I am telling here, ఒకసారి మళ్ళీ ఒకసారి ఏంటంటే చెప్పేది, if they don't exhibit those physical properties like hard nature, lustrous nature, sonorous nature, malleability, ductility, good conductors of heat, good conductors of electricity, if they don't exhibit all these physical properties, those elements are called as non-metals. Okay, first definition already explained, the tendency of an element to gain their electrons. They will form electronegative elements and they form anions. That is the first definition. Second definition, the elements which don't exhibit all these physical properties, those physical properties already I told, they don't exhibit all these physical properties, that is called as non-metals. See, non-metals are maybe solids, sulfur, phosphorus, diamond, liquids, bromine, gases, oxygen, nitrogen, hydrogen, neon, argon at room temperatures. Solids are there, most of the elements are gaseous state, some are solid state, some are liquid state. That is about the first one. So most of the elements are soft in nature, most of the non-metals elements are soft in nature except diamond. Diamond is very hard. Diamond is made up of carbon. Carbon is a non-metal, so diamond is a hard in nature. So this is exceptional case. Most of the non-metals are soft in nature except diamond. Let's discuss about this second point. Most of the non-metals are non-ductile nature and non-malleability nature. What is malleability? Metals can be beaten into sheets, but non-metals cannot be beaten into sheets. So those are non-malleability. Second one is that. Third one, most of the non-metals are non-ductility nature. What is ductility? Metals can be drawn into wires. That is called ductility. But most of the non-metals are non-ductile nature. Non-ductile nature. So cannot be drawn into wires. So that is about the ductility. So they won't exhibit malleability, they won't exhibit ductility. Next one. Here most of the non-metals are non-lustrous nature. They don't show the shiny nature, lustrous nature. So that's why non-metals are non-lustrous nature, cannot be polished. But except graphite and iodine and diamond. Diamond is lustrous nature, graphite is lustrous nature, iodine also lustrous nature. Okay, these are the exceptionals we have to remember. Okay now, next. Non-metals are generally bad conductors of heat and electricity except graphite, which is a good conductor of electricity, because if they allow the electricity, because the free electrons are there, free movement electrons, free flow of electrons are present. Because of that free flow of electrons, graphite is a good conductor of electricity, and pi bonds are present. Pi bond is weak when if we pass the electricity, it takes that electricity, it allows the electricity because of that movement of free electrons. Then it is a good conductor of electricity. That is the exceptional case. Graphite is made up of carbon. Graphite is a good conductor of electricity because free flow of electrons. But most of the non-metals are bad conductors of heat and electricity. They don't exhibit physical property, good conductors of heat and electricity. Next, you can call as free electrons, you can call as mobile electrons also. Mobile means moving electrons, free electrons. Next, non-metals can be easily broken due to its low tensile strength. Next, 6 point, non-metals are generally light and they have low density, because these are the soft metals. They have light in weight and low density. Soft metals. Next, unlike metals, non-metals don't produce any sound when struck with an object, because most of the non-metals are sonorous in nature. They won't produce sound. So that's why these are non-sonorous nature. Non-metals are soft except diamond. Already I told you. Non-metals have low melting point and boiling point. Most of the non-metals are low melting points and boiling points except graphite. The graphite melting point is 3730 degrees centigrade. The melting point is very high. Melting point is very high in graphite. But remaining elements, non-metals, less melting points and boiling points. So this is completed. So non-metals fully completed. I explained about non-metals. First examples I explained, general physical properties I explained,